Beneath the vast silence of space, two giants linger, draped in storms older than civilization itself. Jupiter and Saturn, the colossal guardians of our solar system, turn endlessly in the dark, their atmospheres layered like veils of mystery. Their clouds do not merely drift, they roar, they churn, they rage in tempests that have endured since before the first cities rose upon Earth. The great red spot of Jupiter, a storm so wide it could swallow worlds, has raged longer than any human empire. Saturn's pale bands stretch across its surface like ribbons of time, hiding secrets buried deeper than imagination dares to follow. For these are worlds without ground, places where descent means surrender. Beneath their painted skies lie oceans of hydrogen, compressed and crushed into strange metallic states, deeper and darker than any ocean Earth has ever known. To enter is to fall without end, swallowed by pressure, heat, and gravity itself. Yet within these veils, hidden mysteries stir. Are these planets only storms, only endless tempests, with no place to rest a single step? Or do they harbor secret realms within their depths? Could there be hidden layers where matter takes on new and exotic forms? Or unseen landscapes where physics itself bends into shapes not yet understood? And what of their moons? Are they merely frozen stones caught in orbit? Or could they be the true hidden worlds, with oceans beneath their icy shells, seas that might cradle life? Here, at the threshold of the gas giants, awe and danger intertwine. Humanity gazes across the void and wonders, are these swirling titans merely storms? Or do they conceal worlds yet waiting to be found? If you are new here, join the journey, like, subscribe, and let's begin. Long before glass bent starlight into magnification, long before science was a language humanity could speak, the night sky itself was the first scripture. Among the patterns of stars, 5 moving lights roamed. They did not remain fixed like the constellations. They wandered across the heavens with a strange and restless patience. These were the planets, from the Greek planets, meaning wanderers. And of these celestial travelers, 2 appeared unlike the rest. One shone with a steady brilliance, a golden lantern that drifted slowly along the ecliptic. This was Saturn, pale, patient, almost hesitant in its march through the heavens. The other was brighter still, a beacon of light so radiant it often rivaled the stars themselves. This was Jupiter, the king of planets, so dominant that ancient astrologers believed it governed fate itself. To the Mesopotamians, these were gods given form. Jupiter was Marduk, champion of creation, and Saturn was Ninurta, lord of boundaries and time. To the Greeks, Jupiter became Zeus, ruler of Olympus, while Saturn took the name Kronos, the devourer of ages. The Romans, inheriting both myth and sky, gave them the names we speak even now. These lights were not curiosities, they were deities, cosmic symbols that bound the rhythm of human life to the motion of the heavens. For millennia, these giants were known only as lights moving against the backdrop of stars. Their true forms, their immense scale, remained hidden behind distance. The naked eye revealed only their path, never their face. But in the early 17th century, a revolution in vision began. In 1609, Galileo Galilei, an Italian mathematician and philosopher, turned a modest telescope toward the skies. It was little more than a tube of glass lenses, rough and primitive by modern measure, yet it transformed the heavens into something human eyes had never seen. When he aimed it toward Jupiter, what he discovered would shake the very foundations of cosmology. Orbiting the great planet were tiny points of light, 4 in number. Night after night, they shifted their positions, sometimes disappearing into the planet's shadow, sometimes emerging again like loyal attendants. Galileo named them the Medicean stars after his patrons, the Medici family. Today, they are known as the Galilean moons, Io, Europa, Ganymede, and Callisto. This was no minor revelation. For thousands of years, the prevailing belief, reinforced by Aristotle and codified by Ptolemy, was that everything in the cosmos revolved around Earth. It was a model of security, placing humanity at the unmoving heart of existence. But here was proof, clear and undeniable, that not all things circled Earth. 4 worlds danced around Jupiter, a miniature system within the solar system. The center was no longer ours alone. The shock rippled far beyond science. It was philosophical, theological, existential. If Earth was not the anchor of the universe, what was humanity's true place? The discovery of Jupiter's moons was the first glimpse into the vastness of possibility, that worlds beyond Earth might not only exist but thrive. Around the same time, another observer was casting his gaze towards Saturn. Christian Huygens, a Dutch mathematician and astronomer, had built telescopes of remarkable clarity for his era. In 1655, he turned one toward the Golden Wanderer and saw something baffling. Saturn, through the imperfect glass, appeared stretched as if flanked by handles. Theories abounded. Perhaps Saturn had giant moons so close they appeared attached. Or perhaps it was an ellipsoid unlike any other planet. It was Giovanni Domenico Cassini, an Italian-French astronomer, who resolved the mystery with greater precision in the latter half of the 17th century. With sharper instruments, he discerned that Saturn was encircled by a thin, flat ring. What appeared to be solid, he discovered, was not uniform. The ring itself was divided, a great gap that we now call the Cassini division. Saturn was revealed as something wholly alien, a planet adorned with a celestial crown. But if these early telescopic visions unveiled majesty, they also deepened the strangeness. Unlike Earth or Mars, the gas giants displayed no mountains, no valleys, no continents, no seas. There was no terrain to map, no surface to measure, only bands of color, clouds in perpetual motion, and storms so immense they defied comparison. Astronomers peering through their instruments faced a riddle. Were these truly planets in the same sense as Earth, or were they something else entirely? Vast spheres of atmosphere with no ground beneath the storms. The great bands of Jupiter appeared to swirl endlessly, evidence of storms moving with unimaginable force. At times, observers noted an enormous oval, a blemish of crimson drifting across the planet's face. This was the Great Red Spot, though in those early days, no one yet knew its true nature. Some thought it a shadow, others a passing feature. Only centuries later would its persistence be understood, a storm older than modern science itself. Saturn, for its part, revealed a subtler strangeness. Though its rings caught attention, its body appeared softer, hazier, its bands less stark than Jupiter's. Still, its very presence demanded explanation. Why should this planet, and no other, possess a system of rings so delicate, so improbable? Were they solid, or were they swarms of countless fragments? The answer, like so many truths of the gas giants, would remain hidden for centuries. These discoveries marked the beginning of a shift in human perspective. The planets were no longer distant points of wandering light, nor were they merely metaphors in myth. They were revealed as worlds, immense, turbulent, and strange. Yet with each revelation came greater questions. If Jupiter could hold moons as large as planets, what lay within its hidden atmosphere? If Saturn's rings could encircle it with such precision, what forces sculpted their shape? And most perplexing of all, what exactly were these giants made of? Unlike Earth, whose surface could be charted and whose seas could be sailed, the giants offered no such invitation. To imagine descending into them was to imagine falling without end, swallowed into depths that defied comprehension. Early astronomers recognized that the very nature of these worlds was unlike anything known before. They were planets without surfaces, storms without boundaries, realms defined not by land but by motion, pressure, and cloud. The first giants had been revealed, yet in their revelation lay the seeds of mystery. The telescopes of Galileo, Huygens, and Cassini had pierced the heavens and shown humanity that the solar system was not a single world with attendants, but a complex orchestra of wandering giants and their retinues of moons and rings. Still, the instruments of their time could only hint at the truth. What lay beneath the visible bands of cloud? What secrets slept beneath the veils of hydrogen and helium? Were these planets merely gaseous storms, or did they harbor deeper, hidden worlds within? The discovery phase was less an ending than an opening, the unveiling of questions that would echo across centuries of astronomy. With each observation, humanity moved further from the certainty of Earth-centered thought and closer to the recognition that the cosmos was vaster, stranger, and more intricate than imagination had allowed. Jupiter and Saturn had stepped forward from the night sky, and in their emergence, they began to change the way humanity saw itself. The giants had been revealed, yet they remained veiled. They were worlds, yes, but not worlds like Earth. They were mysteries clothed in light, guardians of secrets yet to be uncovered. And for the first time, humanity realized that the solar system was not merely a stage for one world, but a vast and layered reality where the greatest truths lay hidden, waiting beneath the storms of the giants. For centuries, humanity measured its sense of place by the certainty of ground. To exist was to stand upon something solid, to build cities upon stone, to walk across continents that resisted the weight of steps. Every known world followed this logic. Earth, firm beneath the oceans and soil. The moon, barren and silent, but solid still. Mars, a ruddy sphere of deserts and mountains. Even Venus, wrapped in its veil of cloud, was assumed to have a rocky surface below. To be a planet, it seemed, was to possess land. But Jupiter and Saturn defied that expectation. They were vast beyond comparison, their volumes dwarfing the Earth many times over. Yet as telescopes sharpened and theories advanced, the unsettling truth emerged. These giants were worlds without ground. To descend into them was not to land, but to fall. The realization grew slowly, piece by piece. Observers noted the absence of any fixed surface beneath the clouds. Unlike the Moon or Mars, no craters or mountains showed themselves through the haze. The swirling bands of Jupiter and the pale belts of Saturn betrayed no solid landscape beneath their turbulent faces. Early astronomers wondered, if no land appeared, was it simply hidden deeper? Or were these planets nothing more than atmosphere, infinite storms with no end? In time, physics supplied the answer. As models of planetary structure matured, it became clear that Jupiter and Saturn were composed primarily of hydrogen and helium, the same gases that ignite stars. If Earth is a sphere of rock, and Neptune and Uranus are worlds of ice and water, then Jupiter and Saturn belong to another category entirely, the gas giants. Their atmospheres stretch downward with no clear boundary, deepening into pressures that defy human comprehension. At the cloud tops of Jupiter, the air pressure resembles the sea level of Earth. Yet with every imagined kilometer of descent, the weight grows crushing. Within tens of kilometers, pressures climb to levels that would obliterate any human craft. Deeper still, hydrogen itself, the lightest of all elements, begins to change. Under the immense gravity of these giants, hydrogen does not remain a gas. It compresses into liquid, flowing as vast oceans hidden far below the storms. And deeper yet, something stranger occurs. Hydrogen, crushed and squeezed into submission, takes on metallic properties. This was the first shock, that within the hearts of Jupiter and Saturn exist oceans of metallic hydrogen, a form of matter never witnessed on Earth except fleetingly in laboratories under conditions of extreme compression. In these alien seas, atoms lose their individuality. Electrons drift freely, allowing currents and fields to move unimpeded. The result is a conductor unlike any other, a vast planetary engine that generates magnetic fields of staggering power. Jupiter's magnetic field, sculpted by this hidden ocean, is so immense it could fit all of Earth within its embrace. The concept seemed almost unthinkable to the scientists of earlier centuries, that planets could harbor oceans not of water, but of metallic hydrogen, that storms could rage above surfaces that were never meant to be walked upon. Worlds without ground blurred the very definition of what it meant to be a planet. For some, the giants resembled stars that had failed to ignite, stellar bodies arrested before fusion, existing on the threshold between planet and sun. The imagery of their storms only deepened the mystery. Jupiter's great red spot, first recorded in the 17th century, revealed itself as a hurricane so vast it could swallow 3 Earths side by side. Its winds rage at hundreds of kilometers per hour, its colors shifting through centuries, yet the storm itself endures. When empires have risen and fallen, when revolutions have remade nations, the Great Red Spot has continued its endless rotation, an unblinking eye in the atmosphere of the largest planet. No storm on Earth could survive so long. Our tempests fade, torn apart by land and sea, their energy dissipated. But on Jupiter, there is no land to end them, no coastlines to break their force. The atmosphere provides no boundary, only deeper layers to draw upon. Here, storms can last not days but millennia, sustained by the ceaseless churning of heat and motion. It was another blow to Earth-centered understanding, that even weather, something so familiar, could behave in ways utterly alien when freed from the constraint of land. Saturn, too, concealed its enigmas. Its pale atmosphere appeared softer, its storms less visible, yet hidden within were tempests that burst forth without warning. Once every few decades, a great storm encircles the planet, a white eruption so large it stretches across its circumference. These tempests, called great white spots, scar Saturn's atmosphere for months before dissipating into memory. And deep within Saturn's pole lies a geometric impossibility. The hexagon, a six-sided jet stream so vast it could engulf Earth, spinning steadily, unchanging, its origins still debated. What unsettled early science most was not only the strangeness of these features, but what they implied about the giants themselves. If there was no surface, no place where storm met ground, then the very categories of planetary science were dissolving. To call them worlds was to stretch the meaning of the word. What is a world without land? What is a planet without a surface? The disbelief was understandable. For thousands of years, philosophy had tethered the idea of reality to solidity. Even in language, the word ground means not just soil, but certainty. To ground an idea is to make it real, to anchor it. Jupiter and Saturn offered no such anchor. They were revelations of instability, realms where descent never ended. Where the farther one fell, the stranger the matter became. As models of planetary interiors grew more refined, another shock followed. The very cores of Jupiter and Saturn may not exist in the way once imagined. Some theories suggest a solid heart of rock and ice, buried beneath thousands of kilometers of gas. Others propose fuzzy cores, regions where elements dissolve and mix, where boundaries blur between core and atmosphere. In these giants, even the idea of a center dissolves into uncertainty. This dissolution of certainty carried philosophical weight. If Earth had taught humanity that a planet is a place of ground, seas, and sky, then Jupiter and Saturn taught a different lesson, that a planet is not defined by resemblance to Earth, but by the forces of physics, by gravity's dominion over matter. They showed that nature builds not only familiar worlds, but alien ones, where the rules are stretched and definitions falter. The shock of discovery gave way to reflection. The ancients had called them gods, and perhaps in their way they were right. Jupiter and Saturn were not worlds meant for feet or ships or homes. They were vast laboratories of physics, places where matter was crushed into states unseen, where storms rewrote the meaning of weather, where surfaces dissolved into endless descent. They were worlds, yes, but worlds of motion, of fluid, of pressure, of energy. For scientists, the challenge was both exhilarating and unsettling. Could such places truly exist? Was it possible for planets to be built entirely of gas, with no boundary between sky and Earth? The answer lay not in belief, but in data. Gravity, mass, density, the measurements all aligned. These giants could not be rocky. They were too massive, too diffuse. The numbers spoke clearly. They were worlds without ground. The revelation reshaped astronomy. No longer could planets be understood as mere Earths repeated in different forms. The universe, it seemed, was capable of building structures that defied the imagination of those who looked only through the lens of the terrestrial. The gas giants expanded the definition of what a world could be, opening the door to even stranger possibilities beyond the solar system. To gaze upon Jupiter and Saturn is to confront this truth directly. They are planets not of solidity, but of possibility. They remind humanity that the cosmos is not obliged to conform to expectation, that the very idea of a world can be broader, stranger, more fluid than the ground beneath our feet. And as their storms rage on, as their oceans of metallic hydrogen continue to churn in darkness, they stand as emblems of the scientific shock that reshaped our understanding, that not all worlds are meant to be walked upon, and that some exist only to be witnessed from afar, forever veiled in mystery. They circled in silence, overlooked at first, faint points of light drifting around the titans of the outer solar system. To early astronomers, they were little more than moving stars, appendages of worlds already shrouded in mystery. But as glass grew sharper and the reach of human vision expanded, these companions revealed themselves as more than satellites. They were libraries of secrets, orbiting archives, each one carrying a fragment of the deeper story of the gas giants. The closer science looked, the clearer it became. The true keys to the giants' mysteries did not lie hidden in their crushing atmospheres, but in the icy, rocky worlds that wheeled endlessly around them. Europa emerges first, gleaming like a frozen pearl in Jupiter's orbit. From a distance, it is unremarkable, a sphere wrapped in white. But as Voyager swept past in 1979, its cameras revealed something startling. A crust of ice, etched with scars, cracks, and strange reddish lines stretching for thousands of kilometers. These were not mountains nor valleys, but fractures in a frozen shell. Beneath that shell, evidence suggested, waited a secret ocean, locked beneath kilometers of ice. That ocean may hold more water than all of Earth's seas combined. Tides from Jupiter's immense gravity knead the moon like dough, generating heat in its core. The result is a hidden sea, liquid in the cold void, sealed in darkness but restless with energy. On Earth, where there is water, there is life. The question whispered through astronomy was profound. Could Europa's depths, unseen and unlit, harbor biology stranger than imagination allows? Another world, larger than Mercury itself, spoke in a different voice. Ganymede, Jupiter's giant moon, revealed itself not as a dead rock, but as something startlingly complex. Magnetic instruments on the Galileo spacecraft confirmed that Ganymede carries its own magnetic field, unique among moons. Within, scientists believe, lie multiple layers of water, oceans stacked between slabs of ice, a vast, tiered world hidden in silence. To orbit Ganymede is to witness a planet in miniature, a sibling to Earth disguised as a moon. Its magnetosphere interacts with Jupiter's in luminous auroras that ripple across its poles, painting the darkness with ethereal light. The presence of liquid water, layered and shielded, reframed what a moon could be. Ganymede was not an afterthought, but a world in its own right. Perhaps a more promising candidate for habitability than some planets. Further outward, Saturn too unveiled its secrets. One of its smallest companions, Enceladus, once dismissed as a frozen, unimportant sphere, revealed its hidden fire. In 2005, the Cassini spacecraft passed close and saw something astonishing. Geysers of water erupting from fissures at its south pole, plumes venting into space, shimmering against the black backdrop of Saturn's rings. Those plumes contained not just water vapor, but salts, simple organic molecules, and even complex chemistry suggestive of hydrothermal activity below. The implication was staggering. An ocean beneath Enceladus's crust, warmed not by sunlight, but by the tidal flexing of Saturn's gravity. Beneath kilometers of ice, liquid seas churn against a rocky core. Where rock meets water and heat, chemistry unfolds, chemistry that, on Earth, became the first spark of life. Enceladus was no longer small. It was a window into possibility, a beacon calling across the void that oceans need not bathe in starlight to exist, and life need not be confined to familiar Earth-like shores. Yet the strangest of them all circles Saturn in a haze. Titan, wrapped in an orange atmosphere thicker than Earth's, stands as a riddle unmatched. For centuries its face was hidden, veiled in smog. Only radar and infrared eyes could pierce it. What they found was a landscape eerily familiar and profoundly alien. There were rivers carved into valleys, not by water, but by liquid methane. There were lakes, seas, and rainfall, not of water, but of hydrocarbons. It was a hydrological cycle stranger than any imagined, a world of cold chemistry, where methane and ethane fill the role of water, shaping the terrain into coastlines, channels, and deltas. The Huygens probe, descending in 2005, touched Titan's surface and saw rounded pebbles, sculpted by ancient liquid flow. Here was a place where alien rain fell, where shorelines glistened beneath a golden sky. Some speculate that beneath its icy crust lies yet another ocean of water, salted and deep, hiding below the methane-soaked landscape. Titan was not barren. It was alive with weather, geology, and mystery. As each moon revealed its nature, the question shifted. The gas giants themselves, with their storms and impossible pressures, seemed inhospitable, their hidden layers beyond reach. But their moons reframed the search. Perhaps the hidden worlds were not buried beneath atmospheres of crushing hydrogen, but orbiting quietly nearby, each a stage for its own drama. Europa's secret seas, Ganymede's magnetic shield, Enceladus's geysers of life-bearing chemistry, Titan's rivers under alien skies. They became more than companions. They became keys, each unlocking a different door in the labyrinth of what it means to be a world. The shock was philosophical as much as scientific. For centuries, humanity defined a world as a place like Earth, rock, sky, ground beneath one's feet. The gas giants challenged that definition, presenting spheres without surfaces, storms without soil. But their moons whispered another truth. A world could be a hidden ocean beneath ice. A world could be a haze-shrouded landscape of methane rivers. A world could exist where heat comes not from a sun, but from the crushing embrace of gravity. These discoveries unsettled the very language of astronomy. Planets and moons, once neatly divided, blurred together. Which were the true planets? the massive spheres of gas with no surface, or their smaller companions that carried oceans and atmospheres more complex than Mars or Venus? The investigation deepened, and so did the wonder. With each probe, each flyby, the picture grew richer. The giants, once thought of as storms and spheres of gas alone, were revealed as systems, miniature solar systems, with environments more diverse than any one planet could hold. The moons became destinations. They became frontiers not of myth but of science. For in their oceans, their atmospheres, their geysers and rains, lay the most haunting possibility of all, that life might not be confined to Earth, that biology may already exist, hidden away beneath layers of ice or in seas of methane, waiting silently for discovery. And so, as telescopes sharpened, as spacecraft slipped deeper into the cold reaches of the solar system, the search no longer asked only what Jupiter and Saturn were. It asked what worlds might be orbiting them, and whether some of those worlds might, against all odds, breathe. The deeper the gaze of science reached, the stranger the gas giants became. What began as glimmers in telescopes, what unfolded as icy moons with hidden seas, now gave way to questions of interiors, of forces unseen, of mysteries multiplying with every new probe sent into the darkness. When the Cassini spacecraft arrived at Saturn in 2004, its mission was to study rings, magnetospheres, and the chemistry of a distant world. But what it discovered was a revelation. Small moons once thought of as frozen relics, awakened as dynamic bodies. Enceladus, with its shimmering plumes, forced astronomers to reconsider everything. Cassini's instruments detected salt in the spray, evidence of liquid water in contact with rock far beneath the icy crust. This was not an inert snowball, but a living system of heat, chemistry, and motion. Each plume was a message ejected into space, carrying with it the signatures of complex organic molecules. Carbon, hydrogen, nitrogen, the raw ingredients of biology, drifted outward in vapor and ice. Saturn, it seemed, was not a silent giant. It was a host to processes that echoed Earth's most primordial beginnings. Farther out, the Juno mission plunged into the gravity of Jupiter in 2016. Its polar orbit carried it close enough to skim the cloud tops, gathering data in detail no telescope could achieve. What it found was staggering. The Great Red Spot, a storm older than civilization, was not a shallow swirl of atmosphere. Juno's measurements revealed that its roots extend thousands of kilometers downward, far deeper than expected. The storm was not just weather, it was structure, as if woven into the very body of the planet. Other cyclones, clustered at the poles in perfect geometric arrangements, defied understanding. At Jupiter's North Pole, storms arranged themselves into a hexagonal symmetry, each cyclone locked into place by forces not fully explained. At the South Pole, similar patterns spiral in perpetual motion, as though nature itself paints with geometry in a medium of hydrogen and helium. The question grew sharper. How deep do these storms go? Do they fade into calm? Or do they descend endlessly into layers so compressed that hydrogen itself changes form? Scientists once imagined Jupiter and Saturn with simple interiors. Cloud tops, gas layers, a solid core of rock or ice. But data began to fracture that model. Juno detected chaotic gravitational fields, signals suggesting that Jupiter's interior is not uniform, not neat. Instead of a solid central core, it may have a diffuse, smeared region where heavy elements are dissolved into metallic hydrogen. The boundary between core and mantle, once thought sharp, now appears blurred. Saturn offered its own revelations. Cassini, in its final orbits before plunging into the planet, measured the tug of gravity across its rings. Those measurements suggested that Saturn's core, too, may be vast, not compact. A region of slushy mixtures extending tens of thousands of kilometers, unstable and strange. These were not worlds of clear boundaries. They were worlds of gradients, of matter in unfamiliar states, of physics stretched to the breaking point. And then came the rings. Saturn's rings had long been admired as decoration, fragile arcs of ice orbiting like jewelry. But Cassini revealed they were far more than ornaments. The rings behaved as cosmic seismographs, recording vibrations deep within Saturn itself. Waves seen rippling through the rings matched oscillations inside the planet, like sound reverberating through a drum. By studying those ripples, scientists could listen to Saturn's interior, detecting shifts in mass, hints of layers, even signatures of unseen motions. The rings were not passive. They were instruments, whispering secrets about the heart of the giant they circled. Even stranger, interactions between the rings and nearby moons suggested that the system was alive with feedback. Tiny moons opened gaps in the rings, sculpted edges, and in turn were tugged by the very waves the planet generated. A dialogue played out between moon, ring, and planet, written in gravity and ice. Mystery multiplied, not only in the physical, but in the energetic. Jupiter's magnetic field, measured by Juno, turned out to be far more lopsided than Earth's tidy dipole. Regions of intense flux erupted near the equator, while elsewhere the field twisted unpredictably. Beneath the storms, something stirred the planet's dynamo in unexpected ways. Saturn, too, cloaked its secrets in magnetism. Its magnetic field is almost perfectly aligned with its rotation, a fact that should be impossible. Theories of planetary dynamos predict some degree of tilt, a wobble that allows scientists to measure rotation precisely. Saturn's symmetry hid its spin, leaving astronomers uncertain of the true length of its day. The field itself became a paradox, as though Saturn refused to reveal its innermost rhythm. The escalation of discovery was not only scientific but philosophical. Worlds without ground were already a shock, but now, even their insides defied comprehension. What does it mean for a planet to lack a solid core? What does it mean for a storm to sink thousands of kilometers, merging with the deep? These were not planets in the Earth-like sense, with crusts, mantles, and cores. They were vast laboratories of matter in transition, hydrogen pressed into metallic seas, gravity warping fluids into storms that could swallow Earth whole, magnetic fields sculpted by hidden flows. They were not static. They were dynamic, energetic, alive in ways that defied the quiet sterility once imagined. In their midst, the moons and rings reframed the question of what a world even is. A storm, thousands of kilometers deep. Is that a world? A diffuse core smeared across half a planet. Is that a world? A ring, resonating with planetary vibrations, behaving like a seismograph written in ice. Could that too be a kind of world, energetic and responsive? The boundaries of definition blurred. Worlds were no longer only rocks or spheres with surfaces. Worlds could be storms, magnetic fields, oceans beneath ice, rings alive with resonance. The giants taught astronomy a lesson in humility. The universe is not constrained by Earth's categories. The mysteries multiplied with every revelation. Cassini's dive into Saturn ended with silence, its final signals consumed by the giant's atmosphere. Juno continues to circle Jupiter, peeling back layers, mapping magnetism, listening to storms. Yet for all that is learned, the questions deepen. What lies at the hearts of these worlds, if hearts exist at all? How deep do the storms descend, and do they ever end? Are rings mere debris or dynamic participants in a planetary symphony? The answers, elusive and incomplete, point to a truth more profound, that the gas giants are not only places, but processes. They are not merely spheres of matter, but evolving systems of energy, gravity, and chemistry. And in that realization, the story expands. For the hidden worlds here are not only physical, they are also energetic. Storms as old as civilizations, magnetospheres vast enough to engulf moons, rings tuned like instruments to the pulse of a planet. Each discovery multiplies the mystery. Each revelation deepens the question. The giants once thought simple and distant, now loom as some of the strangest entities in the solar system. Guardians of secrets still locked away in cloud and field, waiting for the next probe, the next orbit, the next glimpse into their endless veils. Beyond the swirling clouds of the gas giants, beyond the storms that have raged for millennia, the imagination of scientists begins to wander into realms both tangible and speculative. The discoveries of moons and hidden oceans have transformed these planets from mere curiosities into theaters of possibility. Each probe, each observation unfolds questions not only of composition, but of potential, of life, of matter, and of worlds that defy terrestrial norms. Europa and Enceladus, locked in the gravitational embrace of Jupiter and Saturn, reveal themselves as guardians of liquid water beneath ice. On Europa, kilometers of frozen crust conceal an ocean kept liquid by tidal flexing, the ceaseless kneading by Jupiter's immense gravity. Beneath the fractured ice, thermal energy could warm hidden seas, creating conditions familiar in their essence, if not in their context. Warmth, liquid water, and chemical gradients. These are the very elements that on Earth have fueled ecosystems for billions of years. Hydrothermal vents, hissing on the ocean floors of our own planet, provide a haven for life independent of sunlight. Could Europa host analogous habitats? Microbial life thriving in darkness, chemotrophic organisms feeding on minerals dissolved in seawater. It is a speculation grounded in the hard evidence of physics and chemistry. Enceladus is more immediate in its revelation. Cassini observed plumes of water shooting from fissures near its south pole, carrying salts, simple organics, and hints of nitrogen. The ocean beneath is not inert. It interacts with a rocky core, allowing chemical reactions akin to those that nurture life on Earth's ocean floor. Each plume is a whisper of possibility, a spray of water vapor, a messenger across space, carrying the building blocks for life into the void. Here, in this tiny moon scarcely 500 kilometers across, the imagination stretches toward the profound. The smallest bodies may harbor some of the grandest possibilities. Titan offers a different, stranger canvas. Shrouded in its thick orange atmosphere, it is a world of hydrocarbons, of methane and ethane cycling across the surface like water on Earth. Rivers carve valleys, lakes gather in depressions, and clouds rain methane in a cold mimicry of terrestrial weather. Could chemistry, unfamiliar to our senses, sustain life here? Life based not on water, but on liquid methane, utilizing radically different biochemistry, perhaps slow and cold, yet adapted to the rhythm of Titan's frozen cycle. The Dragonfly mission, set to explore the moon, promises to probe dunes and rivers for organic compounds, seeking signatures of processes that might mirror metabolism or replication, under conditions that challenge every assumption about habitability. Within Jupiter itself, the mind of theorists drifts into realms of extreme physics. Metallic hydrogen, formed at pressures millions of times greater than Earth's atmosphere, flows in oceans beneath the visible clouds. Here, hydrogen atoms are stripped of electrons, forming a conducting fluid, potentially superconducting under the right conditions. These oceans generate Jupiter's magnetic field, but speculation extends further. Could they also host phenomena unseen anywhere else in the cosmos? Electrical currents flowing in metallic hydrogen might create exotic chemical environments, interactions beyond terrestrial chemistry, regions where matter behaves in ways still largely theoretical. It is an ocean not of biology, but of physics, where the very rules of conductivity and magnetism are rewritten by pressure and scale. Saturn's core offers a complementary mystery. Observations from Cassini suggest a fuzzy interior, where dense materials mix gradually with the surrounding metallic hydrogen and helium. There is no simple boundary, no solid rock at a defined point. Instead, layers blend into one another in complex gradients, creating regions where heat, gravity, and chemistry interact unpredictably. Theorists propose that these interiors may host phenomena that seem alien to human experience. Convection currents generating magnetic fields, thermal layering that drives planetary evolution, and perhaps zones where exotic ices form under unimaginable pressures. Here, the nature of matter itself is in flux, behaving differently than it would on Earth, producing conditions both extreme and beautiful in their orchestration. The moons, the rings, the interiors. Together, they paint a vision of hidden habitats that span more than the biological. There are realms defined by energy, by magnetism, by extreme chemistry, each a potential crucible for processes that challenge the notion of a world. Europa's ocean is a habitat of liquid. Enceladus's geysers a habitat of chemistry in motion. Titan's seas a habitat of hydrocarbons. Jupiter's interior a habitat of exotic states of matter. And Saturn's core a habitat of gradients and flow. Each expands the concept of a world beyond rock and ground, suggesting that the universe creates environments where the laws of physics allow something utterly novel to arise. Speculation extends into the philosophical. If life requires liquid water, energy, and chemical gradients, then these moons become candidates for life without sun, life in darkness, life in the cold. If the universe permits metallic hydrogen to behave as a conductor, then perhaps Jupiter's interior is not lifeless, but active in ways beyond biology. A dynamic system where physics itself operates as a hidden ecosystem, currents flowing, fields generating energy in patterns we have yet to decipher. The notion of habitability is no longer limited to the temperate zones of rocky planets. The giants and their moons propose a spectrum of possibility. Life or processes adapted to extremes, a universe where stability is rare and yet, paradoxically, opportunity flourishes in chaos. Europa may host microbial organisms living near hydrothermal vents, feeding on sulfur compounds and minerals. Enceladus may harbor suspended ecosystems in its ocean, cells or prebiotic molecules ejected by plumes as cosmic emissaries. Titan may offer slow, cold, exotic metabolisms operating in methane seas, perhaps forming structures and cycles alien to our senses, but sustaining continuity over eons. Beyond biology, the planets themselves may harbor exotic physics as an unseen life of energy. Metallic hydrogen generating currents that flow like rivers in an invisible ocean. Layers of helium rain descending in Saturn. Magnetic fields bending and twisting, storms plunging deep, resonating through the bulk of the planet. The very mechanics of the giants are processes in motion, hidden worlds not of flesh but of force and matter, each interacting with moons and rings in ways that blur boundaries between one world and another. The rings of Saturn, once considered merely decorative, become instruments of insight. Ripples, gaps, and waves map interior motion. Gravitational interactions with moons sculpt their edges. They are both witness and participant in the planetary drama, a record of energy transmitted through ice and dust, revealing the otherwise invisible activity of the planet itself. Even the empty space between moons and rings becomes a landscape, where gravitational resonance traces patterns that stretch across thousands of kilometers, invisible to sight yet measurable to those who listen. Here, speculation is grounded in evidence. The physics of tidal heating, the chemistry of hydrothermal vents, the conductivity of metallic hydrogen, the dynamics of planetary interiors, all are well studied and observable. The imagination is anchored in reality, extended into questions that the universe itself invites. Each moon, each storm, each hidden layer is a site of inquiry, a door to what could exist, what might survive, what might be sustained in silence, away from the warmth of the sun. Thus, the hidden worlds multiply. They are oceans beneath ice, atmospheres rich in organics, rivers of methane, seas of metallic hydrogen, gradients of matter in planetary cores. Some may host life in forms familiar or alien. Others are habitats of force, energy, and exotic chemistry. They challenge the definition of a planet, the conditions for life, and the very imagination of science. The question remains, hovering like the thin haze of Titan's atmosphere, how far can life, or process, or organized matter extend? What ecosystems exist where we cannot yet see? What dynamics unfold in the layers we cannot probe directly? And what does it mean to call a world habitable, when that world is no longer defined by land, air, or sun, but by oceans of hidden water, by currents of exotic matter, by fields of energy flowing unseen? In the end, speculation is not mere fantasy. It is the bridge between observation and comprehension. Europa, Enceladus, Titan, Jupiter, Saturn, each offers a tableau where science measures, theorizes, and imagines. Each pushes the limits of what we understand about matter, chemistry, energy, and life itself, and each invites reflection. The universe is stranger than the mind can fully grasp, and yet through inquiry and imagination, glimpses of these hidden worlds become possible, fleetingly, in the minds of those who study the heavens. The gas giants, once considered simple wandering lights, now reveal a network of complex interacting systems. Their moons, their interiors, their rings and storms, all form a tapestry of hidden worlds. Some are physical, some energetic, some chemical, and some may yet harbor life. The theories, rooted in observation and extended by imagination, suggest a cosmos of extraordinary diversity, where the definition of a world is no longer fixed, and where the line between physics and possibility is blurred into something altogether wondrous. In contemplating these giants and their moons, humanity confronts the limits of understanding and the immensity of curiosity. The oceans beneath ice, the metallic hydrogen deep in Jupiter, the methane lakes of Titan, the fuzzy layers of Saturn, all suggest that the universe is not merely vast, but creative, constructing realms where even the rules of earthly expectation bend. These are worlds where discovery is ongoing, speculation is justified, and imagination is measured by the rigor of physics. And in that interplay of observation and wonder, the hidden worlds surrounding our gas giants emerge not merely as objects of study, but as symbols of the vastness of possibility, of the adaptability of matter, of the tenuous boundary between what is known and what may exist. The giants do not yield their secrets easily. Storms rage beneath cloud tops, metallic hydrogen flows silently in deep interiors, and icy moons guard oceans hidden for billions of years. Yet, humanity has learned to craft eyes to pierce these veils, to listen to the subtle murmurs of worlds that neither speak nor pause. Our instruments have become extensions of curiosity, vessels of perception capable of reading the invisible, measuring the intangible, revealing the hidden rhythms of planets that seem, at first glance, eternal and unknowable. Juno, in its daring polar orbit around Jupiter, has brought the planet into unprecedented clarity, not by looking with light alone, but by listening to the subtle distortions of gravity and magnetism. Each pass measures the pull of Jupiter on the spacecraft, revealing the distribution of mass within. Magnetic fields, mapped with exquisite precision, trace the invisible architecture of flowing metallic hydrogen. Aurorae shimmer across the poles, not merely displays of light, but signatures of charged particles interacting with the giant's immense magnetic field. Through Juno, the storms of Jupiter are no longer abstract. They are forces tied to internal flows, their intensity measured in megawatts, their depth calculated in thousands of kilometers. The Great Red Spot, once a symbol of chaos, is now a living system in 3 dimensions, twisting and flowing in accordance with the hidden currents beneath. Juno does not merely observe, it deciphers, translating motion, magnetism, and gravity into a language humans can comprehend. Farther out, Cassini's mission to Saturn transformed our understanding of a planet once thought serene, adorned with rings. For over a decade, Cassini traced the curves of Saturn's magnetosphere, captured the delicate movements of ring particles, and measured the composition of moons. Its final plunge in 2017 was a farewell to science that left a legacy beyond imagination. In its last orbits, Cassini skimmed between Saturn and its innermost ring, a space previously unvisited by any craft. Instruments recorded subtle gravitational perturbations, revealing details of the planet's interior, hints of a core more diffuse than expected, currents flowing deep beneath gaseous layers, and interactions between ring particles and the planet's field. Cassini listened as the rings vibrated like strings on a cosmic instrument, each ripple a note, each wave a measurement of mass and motion unseen. In its passing, the spacecraft became both observer and participant, measuring the hidden rhythms of a planet that had long guarded its depths. Meanwhile, the James Webb Space Telescope casts its infrared gaze across the solar system. Unlike visible light, infrared can reveal warmth in places otherwise shrouded in darkness. Moons previously indistinct now appear as glowing hints in the cold void. Heat signatures betray hidden oceans, active plumes, or geological processes at work. Europa's subsurface ocean, Enceladus's geysers, and Titan's mysterious warmth under haze all emerge as possible targets, each observation narrowing the boundaries of speculation. Webb does not touch these worlds, but it senses them, translating faint photons into a map of activity that hints at life, at chemistry, at motion where none is obvious to the naked eye. The future of exploration, however, is intimate, precise, and perilous. Europa Clipper, set to arrive in the 2020s, will weave a series of close flybys, skimming kilometers above the icy surface. Equipped with radar, spectrometers, and imaging tools, it will penetrate the ice, measuring thickness, detecting plumes, and analyzing surface composition. Its instruments are designed to detect chemical signatures that might indicate life, salts, organic molecules, and the subtle isotopes that mark biological processes. For the first time, we will have direct reconnaissance of a hidden ocean without drilling, a probe sensitive enough to read the whispers of chemistry beneath kilometers of ice. On Titan, Dragonfly promises an unprecedented kind of exploration. A rotorcraft, spinning through the thick orange atmosphere, will traverse dunes, riverbeds, and methane lakes. Each landing will carry instruments for chemical analysis, seeking prebiotic molecules and assessing the complexity of organic chemistry on the moon's surface. Dragonfly will map the terrain, measure winds, capture meteorological data, and sample the building blocks that, on Earth, precede life. Titan, long enigmatic and obscured, will finally reveal its character, one flight at a time. Together, these missions reveal a new truth. The gas giants and their moons are not static, distant spheres. They are laboratories of extremes. Jupiter's storms probe the limits of fluid dynamics under unimaginable pressures. Saturn's rings chart the vibrations of a massive body in motion. Europa's and Enceladus's oceans test the boundaries of chemical life in isolation. Titan's methane cycle challenges the very definition of habitability. Metallic hydrogen, layered cores, magnetic fields. Each is a system under scrutiny, revealing the interplay of physics, chemistry, and possibly biology. Each tool is designed to uncover what cannot be seen with the eye. The subtle mass shifts that indicate interior flows, the thermal gradients that hint at oceans beneath ice, the electrical currents tracing a planet's dynamo, the chemical signals of prebiotic or biotic activity. Instruments act as translators, turning force, energy, and light into knowledge comprehensible to human understanding. They allow a dialogue with the giants, not of words, but of measurements, revealing that these planets are dynamic, alive in ways that stretch beyond imagination. The choreography of exploration is deliberate. Gravity assists, orbital mechanics, and timing of flybys are calculated with precision to maximize knowledge without risk. Every approach is a negotiation with forces far greater than humanity. Every data packet returned a bridge across millions of kilometers. Each instrument must interpret subtle signals amid a cacophony of cosmic noise, discerning plumes of water, currents in ice, or fluctuations in magnetic fields that hint at worlds beneath. Humanity's eyes in the dark are many and varied. Orbiters, landers, rotorcraft, and telescopes. They complement each other, layering data across scales, from the global to the microscopic. Juno measures gravity, Cassini observes rings, Webb glimpses heat, Clipper skims ice, Dragonfly samples organics. Alone, each mission reveals part of the story. Together, they construct a symphony, instruments converging to render the invisible audible, the unknown visible. The giants themselves, however, continue to challenge assumptions. Storms plunge deeper than any model predicts. Metallic hydrogen flows in ways that remain partly theoretical. The diffuse cores of Saturn and Jupiter defy simple categorization. Rings pulse in resonance with hidden currents. The moons, far from inert companions, interact with their planets in gravitational, magnetic, and chemical feedback loops. Scientific tools are not merely passive observers. They are part of a dialogue between human curiosity and planetary complexity. Each measurement reframes questions. Each observation deepens the mystery. The search for life on Europa or Enceladus is inseparable from understanding the physics of tidal heating that sustains it. Titan's methane lakes demand knowledge of atmospheric chemistry, geology, and weather dynamics. The planets themselves, in motion and flux, are active participants in their own study. In observing these distant worlds, science confronts both scale and subtlety. Instruments must measure changes in gravity of fractions of a millimeter per second, detect plumes of molecules traveling through space at kilometers per second, sense heat differences of a few degrees in an environment hundreds of degrees below freezing. The margin of error is microscopic, yet the stakes are cosmic. The difference between discovery and oversight, between the known and the invisible. This precision is not merely technical, but philosophical. By probing interiors, oceans, atmospheres, and rings, humanity redefines what a planet is, what a moon can be, and what conditions can sustain processes that we call life. Each mission, each orbit, each measurement is a step toward comprehension of worlds that exist at extremes beyond direct human experience. The giants and their moons are laboratories, yes, but also mirrors, reflections of how understanding emerges from careful observation, from patience, from tools that extend senses into realms otherwise unreachable. And yet, even as missions return data, the universe maintains its quiet defiance. The deeper the instruments reach, the more questions arise. How deep do storms descend? How layered are Saturn's core gradients? What interactions govern the moon's hidden oceans? Can chemical signatures reveal biology without direct sampling? Each answer generates further inquiry, a cascade of complexity. The eyes in the dark are tireless. They reveal not just structure and motion, but context and possibility. In the reflections of infrared light, in the measurements of gravitational distortion, in the detection of plumes and aurora, we perceive worlds as they truly are. Active, dynamic, interconnected, and profound. Instruments are our touch across the void, extending human presence into the outer solar system without leaving the Earth. They record, analyze, and translate, but they also inspire, allowing imagination and science to meet. Through Juno, Cassini, Webb, Clipper, and Dragonfly, the gas giants and their moons emerge not as distant curiosities, but as active participants in a dialogue with humanity. Laboratories of physics, geology, and possibly life, their processes ongoing, their mysteries multiplying, their worlds ever more vivid. And in the patience of observation, in the precision of measurement, and in the ingenuity of exploration, the hidden worlds of our solar system slowly, inexorably, begin to yield their secrets to those who know how to look, how to measure, and how to listen to the whispers of the giants. The gas giants do more than dominate the sky with their swirling storms and icy moons. They are architects of the solar system, subtle choreographers whose gravitational fingers have shaped the trajectories of worlds and the very conditions that allow life on Earth. Jupiter and Saturn are not merely distant spheres of gas. They are forces that extend across time and space, their influence weaving a hidden structure whose threads touch every planet. Asteroid and comet, Jupiter, immense and ponderous, guards the inner solar system with its gravity. Simulations of the early solar system suggest that without Jupiter's mass, the asteroid belt might not have formed as it did, and Earth's orbit could have been far less stable. The giant's presence acts as both shield and sculptor, deflecting cometary bodies that might otherwise collide with inner planets, subtly shaping the eccentricities of orbits, guiding the dance of matter through the solar system. Saturn complements this role, its mass and position stabilizing regions of the outer solar system and influencing the Kuiper belt's distribution. These planets are not isolated. They participate in a grand mechanical narrative, invisible yet decisive, the rules of gravity writing patterns that unfold over billions of years. Moons, locked in resonance with their parent giants, are themselves testimony to hidden harmonies. Europa, Ganymede, and Io circle Jupiter in precise rhythmic patterns, their gravitational tugging generating tidal heating that keeps subsurface oceans liquid. Without these interactions, the ice might freeze solid, the hidden seas stagnating in eternal cold. Enceladus, orbiting Saturn, experiences the same gravitational caress, fueling plumes that spray water into space and sustaining chemical reactions that could support life. The resonance is a clockwork, invisible yet ceaseless, converting the motion of planets into energy, sculpting environments in places humans cannot walk. Here, time itself becomes a mechanism of possibility, a hidden engine that drives the conditions for complexity beneath kilometers of ice. Magnetic fields extend these hidden worlds beyond their physical boundaries. Jupiter's magnetosphere, vast and roiling, traps charged particles and protects its moons from solar winds. Saturn's magnetic field, nearly aligned with its axis, envelopes its rings and satellites, shaping the movement of particles, controlling the flow of plasma in its vicinity. These invisible shields are laboratories of physics, zones where space is sculpted by force and flux. They interact with the solar wind, deflect cosmic radiation, and even create auroral displays that shimmer with energy, hinting at the intricate link between a planet and its environment. The giants are simultaneously isolated and omnipresent, their effects stretching far beyond sight. Cassini's final orbits revealed yet another surprise. Saturn's rings, long assumed to be primordial, may in fact be comparatively young, no more than 100 million years old. In cosmic terms, this is a fleeting moment, a reminder that even structures that appear eternal are dynamic and transient. The ring's youth challenges assumptions about stability and longevity, suggesting that the solar system is not a static stage, but an evolving arena where even the grandest features emerge, shift, and fade. Each ripple and wave in the rings is a record of hidden forces, gravitational interactions, collisions, and resonances that trace the interplay of moons, planet, and the solar environment. In these revelations, the concept of a hidden world expands. It is no longer confined to oceans beneath ice or storms thousands of kilometers deep. It encompasses the invisible architectures of gravity, resonance, and magnetism. These giants create and sustain systems that operate on scales beyond human intuition. Their moons, their rings, and even the trajectories of distant asteroids bear their imprint. The solar system is not simply a collection of planets, but a network of forces, a lattice of energy and matter orchestrated in subtle but profound ways. The discovery that Saturn's rings may be young underscores the dynamic nature of this architecture. Rings may form and dissipate, moons may migrate, and internal processes within the giants may alter their behavior over geological time. The hidden worlds are not static. They evolve, interact, and influence the broader system. Jupiter's storms may last millennia, but the gravitational ballet of moons and asteroids is ongoing, shaping environments across the solar system. Every planet, asteroid, and moon is a note in a symphony conducted by these immense bodies. The resonance of moons is particularly striking. Io's volcanic fury, driven by tidal flexing, constantly reshapes its surface, ejecting sulfur and silicate material into space. Europa's ice crust, fractured and shifting, records the ongoing stress of gravitational interactions. Ganymede, with its magnetic field, contributes to the larger electromagnetic environment of Jupiter's system. These interactions are not minor. They maintain energy budgets, drive chemical mixing, and sustain processes that may allow life to persist. In a sense, the giants act as cosmic furnaces, generating energy remotely through the pull and push of gravity, creating conditions impossible to achieve on isolated worlds. Enceladus, though small, exemplifies the power of these interactions. Its geysers, sending material tens of kilometers into space, are powered by tidal heating, a direct consequence of Saturn's gravitational tug and the resonance with neighboring moons. The plumes feed Saturn's E-ring, seeding the system with icy particles and complex molecules. Here, even the smallest moon participates in a planetary network, its hidden oceans sustained by forces that extend across millions of kilometers. The hidden worlds exist not only beneath ice or within gas, but across space, in the gravitational connections and energetic flows that bind system to system. Magnetic fields amplify these hidden networks. Jupiter's field alone is immense, extending nearly 20 million kilometers toward the Sun and beyond, enveloping moons and trapping particles in radiation belts that would be lethal to humans. These fields sculpt the plasma environment, channel energetic particles, and generate auroras of staggering complexity. Saturn's magnetosphere, though weaker, interacts intimately with its rings and moons, guiding charged particles along invisible pathways. Magnetic structures, once thought of as passive byproducts, emerge as active components of hidden worlds, shaping not only planetary surroundings, but the conditions under which chemical reactions and, potentially, life may occur. The hidden influence of the giants also extends to Earth. Studies suggest that without Jupiter and Saturn, the frequency of comet and asteroid impacts on the inner planets would be far higher, potentially sterilizing early Earth or preventing the stable orbits necessary for life. The gravitational architecture provided by these gas giants has acted as both shield and sculptor, quietly determining the conditions that allowed oceans to persist and life to emerge. They are, in a sense, unseen guardians, shaping the flow of time and matter across the solar system. The more we observe, the more the concept of a world itself expands. A world is not only a body with a surface, it is a dynamic field of influence, a nexus of energy, matter, and time. The storms of Jupiter, the icy plumes of Enceladus, the methane lakes of Titan, the gravitational resonances of moons, and the youth of Saturn's rings. All these elements illustrate that worlds are networks, their boundaries defined as much by invisible forces as by physical dimensions. The hidden structures created by the giants, extending across space and time, suggest that the solar system is a single, interconnected organism. Planets, moons, rings, and fields interact in a continuous feedback loop, exchanging energy and shaping the evolution of environments. These mechanisms operate on scales both vast and minute, from kilometers of subsurface ocean to millions of kilometers of magnetospheric reach. They are mechanisms that we are only beginning to understand, yet they govern the architecture of the solar system itself. Speculation, grounded in observation, becomes compelling. Could these hidden mechanisms extend to influence habitability in ways we have not yet measured? Might energy transferred through resonance maintain chemical disequilibria, providing niches where life could exist? Could electromagnetic interactions create environments where exotic chemistry persists beyond Earth-like conditions? Every discovery, from ring vibrations to tidal heating, suggests that the boundaries of possibility are broader than imagined. The hidden worlds are not passive. They are dynamic, energetic, and interconnected. Even the timeline of formation is unsettled. Saturn's rings, possibly young, hint that planetary systems are not immutable. Jupiter's migration during the early solar system may have rearranged orbits, shaping conditions for terrestrial planets. Moons form and evolve under gravitational stress. Magnetic fields shift. Storms erupt, persist, and wane. The hidden architecture is alive, a network of cause and effect spanning billions of years, unseen yet decisive. In contemplating the hidden worlds of the giants, one confronts a profound philosophical truth, that the universe is a network of interdependencies, not isolated points. Matter, energy, and time are woven together in structures that extend beyond perception. The gas giants, in their storms, fields, and moons, reveal that worlds are not merely places to be visited or observed. They are systems to be understood, complex and subtle, operating across distances and scales that dwarf human experience. The mysteries multiply and deepen. The giants' hidden oceans, resonant moons, protective magnetic fields, and dynamic rings illustrate that every measure we take, every instrument we send, reveals both answers and new questions. The hidden mechanisms of time and matter are active, shaping environments, protecting life, and orchestrating forces across the solar system. They remind us that discovery is never complete, that understanding is provisional, and that the cosmos always contains more than what the eye can see. In the end, the gas giants and their moons are revelations of subtlety and scale. They are storms that extend through thousands of kilometers, oceans beneath ice, dynamic rings, and fields that stretch across space. They are architects of planetary order, guardians of orbital stability, and creators of hidden energetic networks. The hidden worlds are not merely the moons or the gas within. They are the invisible structures, the resonances, the forces that govern the motion of everything around them. The mysteries are as vast as the planets themselves, extending across space and time. Each discovery, each measurement, each observation pulls back a veil, but also reveals new layers of complexity. The giants are both known and unknowable, their hidden mechanisms of time and matter shaping the solar system in silence, in force, and in ways that may be as vital to Earth as the very air we breathe. In watching storms, listening to plumes, measuring resonance, and tracing magnetic fields, humanity glimpses a truth beyond the immediate. That worlds are networks, that influence stretches unseen, that the architecture of our solar system is a living structure sculpted by the giants. Their hidden worlds are not only within, but all around, interwoven with the very fabric of space and time. The gas giants of our solar system are monuments to scale, storms, and gravity, yet they may only hint at the possibilities that lie scattered across the galaxy. As telescopes peer outward, new worlds appear in patterns both familiar and alien. Exoplanet surveys reveal planets the size of Jupiter orbiting close to their stars, hot Jupiters scorched by stellar radiation, their atmospheres boiling and convecting, yet still retaining vast hidden interiors. Far from the sun, massive gas giants drift in the cold dark between stars, rogue wanderers carrying moons and oceans in perpetual night. If our own Jupiter and Saturn are laboratories, these distant giants may be entire ecosystems of physics, chemistry, and perhaps life, operating in forms beyond imagination. The discovery of hot Jupiters challenges long-held assumptions about planetary formation. These giants, often larger than Jupiter and orbiting their stars in mere days, endure temperatures high enough to vaporize metals. Observations suggest that within these searing atmospheres, extreme pressures could condense metals such as iron into rain, falling in patterns as exotic as they are violent. The storms on these worlds dwarf anything in our solar system. Electric currents spiraling through clouds, winds exceeding thousands of kilometers per hour. Beneath these fiery skies, cores may contain metallic hydrogen, possibly superconducting, a liquid metal ocean swirling beneath a boiling, luminous envelope. Such environments defy Earth-centric intuition, stretching the definition of what a world can be. Yet the strangest revelations may come from planets that travel alone, untethered to any star. Rogue gas giants wandering in interstellar darkness are insulated by their own mass. Heat generated from gravitational contraction and radioactive decay may keep internal oceans liquid, while moons orbiting these giants experience tidal heating similar to Europa or Enceladus. These hidden systems drift through voids devoid of sunlight, carrying entire ecosystems beneath kilometers of ice, oceans shielded from the vacuum and the cold of space. Life, if it exists, may thrive here in forms unimaginable, adapted to chemical energy and gravitational tides rather than photons. The possibility forces a radical shift. Perhaps the universe's most common habitable environments are not Earth-like worlds bathed in starlight, but the dark, subsurface oceans of massive planets. Astrophysical models suggest that the galaxy may be teeming with such giants. Observations of exoplanets show that gas giants are more common than terrestrial worlds of Earth's size. The processes that form stars and planets often yield planets of high mass, able to retain thick hydrogen-helium atmospheres and vast gravitational influence. In the interstellar medium, some of these planets are ejected during early planetary migrations, becoming rogue wanderers. Each giant may carry moons, layers of liquid water, and chemical cycles powered by tides, decay, and metallic interiors. The universe, in this view, could be dominated by worlds hidden beneath clouds, where life might exist far from sunlight and warmth, sustained by physics itself. Titan, Enceladus, and Europa in our solar system hint at this broader pattern. They demonstrate that subsurface oceans can persist where surface conditions seem hostile. If these small moons can harbor internal seas, then the moons of exoplanet giants, vastly larger and more massive, could provide similar or even more extensive environments. Oceans could exist under kilometers of ice, protected from radiation, heated by internal mechanisms, and mixed by gravitational interactions. Chemical gradients, necessary for metabolism, could persist for billions of years, providing stability that surface environments on rocky planets often lack. Subsurface life may not be the exception. It could be the rule. Hot Jupiters, though inhospitable on their surfaces, may conceal layers of stability beneath the convective maelstrom. Models of metallic hydrogen interiors suggest complex phase transitions, regions where matter behaves as a fluid metal, conducting electricity and generating magnetic fields orders of magnitude stronger than Earth's. These fields create magnetospheres capable of shielding moons or hypothetical internal oceans from cosmic radiation, adding another layer of potential habitability. The planet itself becomes an active system. Storms, magnetic fields, tidal heating, and chemical reactions interact in ways that resemble planetary ecology on a scale beyond the terrestrial imagination. Rogue giants, drifting in darkness, offer an even more radical speculation. Free from stellar heating, their atmospheres are cold, yet deep internal heat can maintain liquid layers. Moons orbiting these planets would experience tidal flexing, potentially driving oceans beneath ice crusts. Chemical reactions, driven by radiation or hydrothermal activity, could sustain life entirely independent of sunlight. The vastness of interstellar space may thus be dotted with hidden habitable zones, imperceptible from afar, worlds that challenge our very notion of a habitable planet. Life, if present, would exist in darkness, adapted to chemical energy, insulated from stars, persisting for eons in isolation. Some theoretical models even suggest that exotic forms of matter could exist in these environments. Under extreme pressures, metallic hydrogen may enter phases unknown on Earth, superconducting and flowing in ways that alter planetary magnetic fields. Complex interactions between ionized layers and convective motions could produce electrical currents rivaling those of the Sun. Subsurface oceans in contact with rocky cores might drive chemical complexity, generating energy gradients that could power prebiotic chemistry. The gas giants themselves become laboratories for high-pressure physics, chemistry, and possibly biology, offering glimpses of processes that cannot exist on terrestrial planets. If these ideas hold, the implications are staggering. The search for life may need to expand beyond Earth analogues. Habitable conditions may be far more widespread than previously imagined, existing not in thin habitable zones around stars but beneath the ice of moons, inside gas giants, and on wandering planets in interstellar space. Subsurface ecosystems may be the universe's dominant form of life, persistent, resilient, and invisible from conventional observation. The familiar idea that life requires sunlight, warmth, and a rocky surface becomes a limiting lens, one that these hidden worlds force us to reconsider. The speculation does not exist in a vacuum. Observations of our own solar system guide it. Enceladus's plumes, Europa's fractured ice, and Titan's methane cycles provide proof of principle. Subsurface oceans and dynamic chemistry can exist, sustained by gravitational and tidal mechanisms. Exoplanet discoveries extend this principle to extreme conditions, suggesting that worlds far more massive, isolated, and varied than Earth could also host environments capable of complexity. Planets once considered hostile may be crucibles of chemical evolution, They're hidden oceans incubating the slow processes that, over billions of years, might yield life. Even extreme planets, those subject to metallic rain or searing radiation, may harbor internal layers insulated from their violent exteriors. The more massive the planet, the more effectively it can retain heat and sustain long-lived internal oceans. Magnetic fields provide protection, tidal forces deliver energy, and chemical gradients create conditions for molecular complexity. The universe's most common habitable zones, if this is true, are not the ones we see in visible light, but those concealed beneath the layers of gas, ice, and metal. In contemplating these hidden worlds, one confronts a profound philosophical shift. Life may not be rare because conditions must match Earth. It may be abundant because hidden worlds are ubiquitous. The surface is only one manifestation of a planet, not the full extent of its environment. Gas giants, both near and far, hot or wandering, could be cradles for life, not in the light of stars, but in the quiet, insulated, dynamic layers beneath storms and ice. The cosmos in this sense is not empty. It is full of hidden activity, invisible yet pervasive, a theater of subtle and persistent possibility. These speculations, though rooted in real physics, remind us of the humility required in the face of the unknown. Observations guide imagination, yet each discovery opens new mysteries. Hot Jupiters challenge our understanding of atmospheric dynamics. Rogue giants invite us to rethink habitability, and subsurface oceans redefine where life could persist. The hidden worlds beyond our giants expand the horizon of what is possible, revealing a universe far stranger and more fertile than our senses alone could perceive. In these distant giants, life, if it exists, would experience a universe very different from ours. It would dwell in darkness, insulated from stars, sustained by chemical energy and tidal forces. Yet the principles remain universal. Gradients drive activity. Matter interacts under predictable laws. Energy flows through systems. And complexity emerges where conditions allow. Hidden worlds are not mystical. They are natural, inevitable, and abundant. They invite a profound rethinking of life's distribution, suggesting that the cosmos may be more hospitable than previously imagined, even in places that appear desolate to the human eye. The search for life, therefore, is a journey into the unseen. It is an exploration of storms and ice, of magnetic fields and tidal heating, of chemical gradients beneath layers of gas and rock. Every discovery in our solar system, every plume from Enceladus, every crack in Europa, every pattern in Saturn's rings, hints at possibilities on an unimaginable scale. Exoplanetary giants, hot and rogue alike, may extend these possibilities across the galaxy, their hidden oceans and moons forming a vast, interconnected network of habitable niches. The giants teach us that the universe harbors secrets beyond direct perception. Worlds are not solely defined by surfaces, atmospheres, or distance from a star. They are defined by energy flows, chemical gradients, gravitational interactions, and hidden structures. Life may thrive in isolation, in darkness, and in forms adapted to conditions far beyond Earth's experience. In speculating about these worlds, humanity glimpses not only what might exist, but also the humility required to explore the cosmos. Patience, curiosity, and the willingness to embrace possibility beyond the immediately visible. In the cold light of distant stars, in the infinite dark between them, hidden worlds drift, their interiors warm, their moons in tidal dance, their chemical cycles alive. They are laboratories and habitats, storm-tossed or insulated, extreme or stable, yet unified in their capacity to challenge assumptions. If life exists there, it may be ordinary. If it does not, the conditions themselves are extraordinary. In every case, the giants extend the imagination, reminding us that the universe is vaster, stranger, and more generous with possibility than ever we imagined. The hidden worlds beyond our giants are not figments. They are plausible, measurable, and profound. They extend the definition of habitability. They challenge the human-centric lens, and they hint at a cosmos where life may be more persistent, subtle, and widespread than we can yet conceive. The stormy clouds of Jupiter, the plumes of Enceladus, the methane lakes of Titan, and the metallic rain of distant exoplanets converge into a vision of a universe alive in hidden ways, waiting for the instruments, imagination, and daring of humanity to uncover it. The gas giants loom as silent sentinels at the edge of human understanding, immense and unyielding, their truths hidden beneath layers of roiling gas and crushing pressure. Jupiter and Saturn, visible as wandering lights even to the naked eye, offer only a promise of depth, a hint of the extraordinary that lies below their clouds. They are worlds that humanity will never touch. Planets whose very scale and composition deny the possibility of footsteps or flags planted in their storms. Instead, they are known through shadows, through the faint traces of motion, magnetic fields, and gravitational influence. They are perceived indirectly through the instruments we have designed to interpret the echoes of their existence, yet always retaining a portion of mystery that cannot be bridled or fully measured. To gaze at Jupiter through a telescope is to confront the limits of perception, its swirling storms, the great red spot raging for centuries, the bands of contrasting clouds, all hint at processes so immense that the human mind struggles to grasp them. Yet these visible features are but the surface of a vast and hidden interior, an ocean of metallic hydrogen, turbulent currents plunging thousands of kilometers deep, and possibly a core whose composition and structure defy earthly intuition. Saturn, with its ethereal rings, presents a similar duality: beauty on the surface, intricate gravitational interactions below, an interior that remains a riddle, evolving over billions of years in silence. The giants are vast not only in size but in the scale of their unknowable complexity. In contemplating these planets, one realizes that knowledge itself is limited. Spacecraft, from Galileo and Cassini to Juno, have provided breathtaking insights. Plumes erupting from Enceladus, the fractured ice of Europa, methane lakes on Titan, the magnetic might of Jupiter. Yet each discovery expands the horizon of the unknown rather than shrinking it. Every measured value, every mapped magnetic field, every orbital resonance opens new questions about interiors, chemistry, and the forces at play. The giants teach humility, that some truths exist beyond direct access. That understanding is mediated through layers of inference, measurement, and interpretation, and that mystery is not a deficiency, but a feature of the universe itself. The philosophical weight of this unknowability is profound. These planets are not built for human engagement. They are not designed to be walked upon or directly manipulated. Their scale, mass, and conditions assert a reality that is independent of human desire or imagination. The crushing pressures within Jupiter or Saturn, the radiation belts surrounding their magnetospheres, the extreme storms spanning thousands of kilometers, all make them eternally inaccessible to flesh and bone. Humanity can approach them with instruments and reasoning, but the touch of hand, the immediacy of sensory experience, is forever denied. They exist as reminders that the universe is not anthropocentric. It is vast, autonomous, and indifferent to human proximity. Even their moons, potentially the most promising candidates for life in the solar system, are intermediaries to the giants' larger mysteries. Europa's hidden ocean, heated by tidal forces and fractured ice, offers hope that life may exist beneath the surface. Enceladus ejects plumes into space, hinting at chemical richness. Titan, with its methane rivers and dense atmosphere, suggests alternative chemistries and processes beyond Earth-like norms. Yet even as these moons reveal tantalizing possibilities, the cores and internal mechanics of their parent planets remain largely inscrutable. The giants' interiors are sealed behind enormous pressures, metallic hydrogen, and extreme heat, forming domains of physics and matter inaccessible even to the most sophisticated probes. The contrast between the observable moons and the unreachable interiors of the giants highlights a cosmic duality: the knowable and the unknowable, the accessible and the eternally hidden. Jupiter and Saturn also serve as reminders of scale and temporal depth. Their storms, some persisting for centuries, predate human civilization. Their gravitational influence has orchestrated the architecture of the solar system, guiding the formation and stability of orbits, shielding inner planets from potentially catastrophic impacts. The giants are not only massive in space, but ancient in time. Their existence a testament to processes spanning billions of years. Humanity's engagement with them occupies only a fleeting moment, a mere flicker against their slow and inexorable evolution. The reflection is humbling. Existence on Earth and the search for understanding occurs in a shadow cast by forces we can observe but never fully inhabit. The very concept of a world expands when considering these planets. They are not merely spheres with surfaces, atmospheres, and visible features. They are dynamic, layered systems of energy, gravity, and matter, extending their influence far beyond what the eye can see. Jupiter's storms reach deep into an ocean of metallic hydrogen. Saturn's rings interact intricately with countless icy moons. Magnetic fields, tidal forces, and orbital resonances create invisible architectures, sculpting the solar system on scales both spatial and temporal. To call them planets is an approximation, a label imposed for human understanding, insufficient to encompass their true, layered reality. The philosophical implications of these hidden worlds ripple outward. If the most massive and ancient planets in our solar system retain such profound mysteries, what might exist elsewhere in the galaxy? Exoplanet surveys reveal countless gas giants, some orbiting close to their stars as hot Jupiters, others drifting alone in interstellar space, carrying moons and oceans in perpetual darkness. The universe may harbor a multitude of hidden worlds, environments insulated from human senses, yet active with dynamic physics and possibly biology. The gas giants in our own system thus serve as archetypes, symbols of the universe's capacity for complexity beyond the immediately observable. A caution against assuming that what we can touch or see constitutes the full range of existence. There is a beauty in their inaccessibility. The inability to walk upon Jupiter or Saturn, to probe directly into their interiors, preserves a sense of cosmic reverence. Observation becomes an act of imagination and inference, an exercise in understanding by approximation, by light, motion, gravity, and electromagnetic signature. The giants are both objects of empirical study and keepers of secrets, existing on the boundary between measurable reality and the ineffable. To study them is to acknowledge that some aspects of the universe are intrinsically beyond reach, that the very scale of nature enforces boundaries upon human comprehension. This reflection extends to the broader human relationship with the cosmos. The hidden worlds of the giants remind us that knowledge is often mediated, that instruments extend perception but cannot fully replicate presence. Humanity confronts them through photons, radar, gravitational calculations, and spectral lines, assembling a picture of interiors, magnetic fields, and chemical activity from indirect evidence. Each probe, each measurement, is a dialogue with the unseen, a conversation across distance, scale, and time. In this exchange, we encounter both insight and limitation, and in the tension between them lies a profound lesson. The universe is built not for human access, but for its own architecture, governed by laws and processes that persist independent of observation. The giants' hidden worlds are philosophical mirrors, reflecting the limitations and aspirations of human inquiry. They challenge anthropocentric assumptions, demonstrating that vast ancient systems operate in ways that do not accommodate human immediacy or intuition. Their storms, magnetic fields, and hidden oceans are not puzzles designed to be solved, but phenomena to be understood, to be appreciated, to be engaged with intellectually and imaginatively. They are proof that the cosmos contains realities that exceed comprehension, and that wonder is a necessary companion to understanding. Even as humanity seeks to probe these worlds, to measure, model, and interpret, the core remains unknowable. The deepest layers of Jupiter and Saturn, the extreme pressures, the metallic hydrogen, the internal heat flows, these remain hidden beyond any physical reach. Life, if present, may exist only in niches we have glimpsed indirectly, but the vast majority of these worlds' substance is closed to direct experience. This unknowability is not failure. It is a feature of the universe, a reminder that the cosmos is vast, complex, and not subservient to human desire. In accepting this, a deeper philosophical understanding emerges, that existence encompasses both the measurable and the hidden, the tangible and the inaccessible. The hidden worlds of the gas giants thus inspire both awe and reflection. They are immense, ancient, and dynamic. They shape the solar system while eluding direct contact. Their moons may hold oceans, perhaps even life, yet their interiors remain riddles, and their influence extends far beyond immediate perception. Humanity engages them through instruments and imagination, piecing together truths from waves of light, gravity, and magnetic fields. In doing so, one comes to understand the subtle interplay of knowledge, mystery, and scale. The giants exist as guardians of the unknown, asserting that even in an age of telescopes, probes, and models, some worlds are only partially revealed. their deepest truths remaining beyond reach. They embody the unknowable. They operate on scales of size and time that dwarf human comprehension. They are ancient, predating civilization, shaping the architecture of planetary orbits, shielding and guiding the evolution of worlds. They are laboratories of physics, chemistry, and perhaps life. But they are laboratories that humanity may only ever observe from a distance. In this, they offer a profound meditation. The universe is not constructed for access or convenience, but for the persistence of its own hidden structures. The gas giants challenge the human imagination. They teach that reality is not limited to the immediately observable, that the structures and processes shaping the cosmos extend far beyond the reach of senses and instruments. To understand them is to appreciate both the limits of human perception and the grandeur of natural processes, to see life and habitability not as fixed to Earth-like conditions, but as emerging wherever the laws of physics, chemistry, and time allow. The giants' hidden worlds remind us that mystery is integral to existence, that awe is a legitimate companion to knowledge, and that some of the universe's most profound truths are encoded not in what is easily observed, but in what is hidden. In the final reflection, the gas giants are keepers of cosmic perspective. They are immense, distant, and impenetrable, yet intimately connected to the existence of life on Earth. Their storms, moons, magnetic fields, and hidden interiors offer lessons in humility and wonder. They reveal that the universe is not a collection of points to be mapped and touched, but a vast network of structures, forces, and possibilities that operate on scales far beyond human experience. The giants exist for themselves, not for observation. Yet in studying them, humanity glimpses the enormity of what lies beyond immediate perception. Their hidden worlds beneath gas, ice, and storms are eternal mysteries. They are laboratories of physics, chemistry, and perhaps biology, whose inner workings may never be fully known. They are architects and guardians, shaping the solar system in silence, yet unreachable in their entirety. And in this, they offer one of the most profound lessons of astronomy and philosophy, that the universe is not built for human access, but for the persistence of its own vast and secret architectures. To witness them, to study them, and to contemplate them is to stand at the threshold of the unknowable, and to understand that the pursuit of knowledge is inseparable from the acknowledgement of mystery.